Good morning, good afternoon, good evening all my dear friends, and welcome to this NPTEL MOOC lecture series in DADM, which is data analysis and decision making, which is the first of these 3 different courses which is being floated in NPTEL MOOC. And this is the 4th lecture for DADM 1, which is for 30 hours. So, we are in the first week, and I am Raghunandan Sengupta from the IME department, IIT Kanpur. So, we are discussing the examples of arithmetic mean, geometric mean, and for the geometric mean I gave a very simple example that how we can use the concept of interest rate to find out the overall average interest rate. So, let us continue the discussions further on using for the examples for harmonic mean and so on and so forth. Consider the example of the harmonic mean. So, consider a car travels a distance x with a velocity v1. Consider I am going from Delhi to Jaipur, or I am traveling from Bangalore to Bengaluru to Chennai. Consider a car travels a distance x with a velocity v1 and returns back, that means it returns back from Chennai to Bengaluru the same distance with a velocity v2. So, we want to find out what is the average velocity. So, obviously, in the first case the time taken is x by v1, which is distance by velocity, and the next instant when it returns back the time taken is x by v2. So, the total time taken is x by v1 plus x by v2, which is in the denominator as you can see in the slide. Now, I want to find out the average velocity. So, average velocity would be basically the total distance travelled divided by the total time. Total distance travel is, that means I have travelled from Bengaluru to Chennai and from Chennai back to Bengaluru. So, total distance is 2x and the time taken as I mentioned is x by v1 plus x by v2. So, we can find out the corresponding velocity. So, in this case you will find out that we are using trying to utilize. So, if I want to find out the average velocity, so x both from the numerator and denominator will cancel. So, it will basically be 1 by x v1 plus 1 by v2 divided by 2. So, that means this is the way how you calculate the harmonic mean. Hence, we see that in this case we use the harmonic mean and not the arithmetic mean to find out the average of the speed. That is just an example. So, use of harmonic mean, they can be applied in areas like design of stream flow estimation for waste load allocation. Number 2, estimation of the effective petrochemical and geophysical properties of a heterogeneous system of porous media, and also the example which we considered for finding out the average speed between 2 cities, or it can be 3 cities, 4 cities also, depending on how the problem has been formulated. So, in case it is 3 cities and consider for the time being the distances are same. So, you are travelling from city 1 to city 2 distance x, city 2 to city 3 distance x, city 3 to city 1 distance x. So, obviously, it will be 3x divided by, in the first case it will be x by v1, then x by v2 and x by v3. So, x cancels and the value would be 3 divided by, in numerator is 3 and then denominator will be 1 by v1 plus 1 by v2 plus 1 by v3. Now, we will consider the case of geometric mean. I have already given the example, I will just repeat it for your own convenience. Suppose you have an investment which earns 10% in the first year, 50% in the second year and 30% in the third year, and we are interested in finding the equivalent average rate of return. Consider it is r for all the 3 years. So, in the first year, if the principal amount is p, the total amount of value of money which you have after the interest rate is added, it will be p multiplied by 1 plus 0.1. In this, after 2 years, it will be principal amount into the interest rate which you earn, which is 1 plus 0.1, which you already know. In the second year, it is 1 plus 0.5, which is for the second year, only for the second year. Now, if we basically want to find out for the third year, the interest rate would basically be 1 plus 0.3. So, the overall total value would be p into 1 plus 0.1 plus 1 plus 0.2 plus 1 into 1 plus 0.3, sorry, not plus, multiplied. And if I think the equivalent interest rate is r, so it will be p into 1 plus r to the power cube. So, in this case we can find out the overall interest rate based on which you can do the calculation comes out to be about 28.97, which is about 29%. So, this would be the average interest rate which we calculate using the concept of geometric mean. Because why geometric mean? Because what you are doing is that you multiplying the interest rate 1 plus 0.1 into 1 plus 0.5 into 1 plus 0.3, multiply all of them and find out the 1/3 the cube root of this. So, it will be 1/3 of this value to the power. 1/3 means not in the division sense. So, that value comes out to be, as I mentioned, 28.97. Now, as I have been mentioning about the median and the mode, even though I did not mention about the mode many times, I did mention about the median. So, I will just try to give the definitions of the median and the mode. The median, which is denoted by mu suffix e, because if you remember when we discussed the mean value, it was only given by the mu without any suffix. So, if the median would be denoted by mu suffix e, the median of our data set is the value below which lies half of the data point and above which lies the half of the data point. That means, you are trying to basically divide the overall data set corresponding the probability to equal halves. So, that is why the Ojai curves which you found out the midpoint divides the total frequency set of values or frequencies, not the values, in frequency into 2 equal halves. To find out the mean, we would basically find out the overall sum of the probabilities from the minimum value to that value such that the probability is 0.5. So, that is why you equate it to 0.5. While mode is the value of a data set which is that occurs the most frequently, the maximum number of times. Hence, the mode would basically be found out for those values for which the frequency or the relative frequency or the probability is the highest. So, small f of mu naught. So, now here the mode is denoted by mu symbol with the suffix naught to basically denote the mode. So, small f suffix mu naught should always be greater than equal to whatever the x values are there onto the left or the right. So, the maximum value. So, now definitions of the variance, which is the dispersion concept, the variance, standard deviation, skewness and kurtosis. The variance value is given by the symbol sigma square, and that is calculated by the expected value of the differences between the actual value x minus its expected value. So, what we do is that we find out the difference between the so called value with its average value, square them up and basically find out the expected value for that. So, that will give me the variance, and if I am talking about the standard deviation, it will be the square root of variance. While skewness and kurtosis have their corresponding values are given in this equation. So, now remember here this mu suffix 3, mu suffix 4, mu suffix 2 are basically the mean value corresponding to the third moment. So, these are the mean values for the third moment, not corresponding to the third moment by itself. These are the mean values corresponding to the third moment, and we find out the values and replace them in the skewness and kurtosis and do the calculations accordingly. So, let us consider a very simple example. We have the following data points which are 5, 7, 10, 7, 10, 11, 3, 5, 5. So, they are not arranged according to starting from the minimum to the maximum, maximum to the minimum. For these points, we can find out the mean value. So, how we find out the mean value is basically add them up, divide by the total number of readings. So, the total number of readings is 9. If I want to find out the median, we will find out the median such that it basically divides the data set into 2 equal halves. The mode would basically be the highest value. So, in this case we find out number 5 occurs, the maximum number of time is 5, and the sigma square values would be calculated corresponding to the formula which is expected value in the bracket x minus expected value of x whole square, and basically we find out the values comes out to be 6.89. Suppose the data are available in the form of frequency distribution. Assume there are k classes and the midpoints of the corresponding class intervals are given as x1, x2 till xk. So, obviously, we have class intervals. So, the intervals have in such a way that the midpoints are given. So, while the corresponding frequencies of those classes are given as f1 to fk, then the total frequency is basically sum of all the values which is f1 plus f2 plus f3 till the last value which is fk. Now, if I want to find out the overall mean, so obviously, it would mean that I am basically multiplying the mid value which basically is a characteristics of the interval multiplied with corresponding frequency. So, it will be xi into fi, sum them up and divide by n, which is basically the total frequency. So, what I am trying to do is that find out the multiplication value of x1 into f1 plus x2 into f2 plus x3 into f3 till the last value, which is xk into fk, sum them up and divide by n. N is basically the sum of f1, f2, f3 till fk. So, that will give me the mean value. If I want to find out the variance for that, it will be, again I am trying to utilize the same formula. It will be xi, which is the middle value which I have considered, x1, x2, x3 till xk, minus the mean value which you have just found out. So, now you will see there is a difference between mu and x bar, is basically I am trying to denote, that is for one is for the population and one is for the sample. I will come to that definition later on. Technically, just remember mu is for the population and x bar is basically for the sample. So, coming back to the formula, it is xi minus x bar whole square multiplied by the corresponding frequencies, because frequencies have to be utilized in order to find out the variances. Then find, and obviously you will as it is standard deviation, hence the 1 by 2 the square root is coming, but technically it will be squared. So, xi minus x bar whole square into fi, sum them up, divide by n, which is the sum of all the probabilities frequencies from f1 to fk, and find out the square root, that will give me the standard deviation. So, coming back to the example of the heights. So, now the frequencies for the class intervals are given 145.95 to 152.95, the second one being 152.95 to 159.95, the last one is 180.95 to 180.95. So, obviously, if I want to find out the overall average value, what I will do is like this. I have the midpoint values here. So, this is x1, this is x2, this is x3, this is x4, this is x5, this is x6. So, the frequencies which I find out is 6, where I am hovering my pen, I am not writing it down. So, let it be f1, second value is about 5. So, this will be f2, third value is 13. So, it will be f3. I am not writing the values, I am just writing the variables of the symbol. The fourth frequency is basically 9, which is f4, fifth value is 2, which is f5, sixth value is 6, which is f6. So, what I do is that sum the values xi into fi divided by the summation of fi, and that will give me the mean value, which I will denote by x bar for the sample. If it is not for the sample, it will denote by mu, but I am not going to consider that. Then the variance would be given by the value of 1 by n summation of xi minus x bar whole square into fi. Now, this one, this value of xi which I find out is basically coming from this equation. So, and this one f n is equal to this one which I have considered. So, based on that I find out the variance, square root of that will give me the standard deviation. So, again the cumulative frequencies are given. So, this is the the median value, which means if I am able to draw the ogive curves. So, this is the value based on which we are doing the calculations. So, the median value is given by mu suffix e, the mean is given by mu, mode is given by mu naught. So, this mu suffix e value, we divide the overall probability in distribution in such a way. So, the probabilities both to the left and the right are 0.5, 0.5. Now, let us consider m groups of observations with respect to means of mu 1, mu 2 till mu m. So, this mu 1 to mu m I am considering they are from the population, but if they are interchanged with the sample observations, they would be corresponding to, let me change the color, this is x1 bar, x2 bar, xm bar, and the standard deviations are given
technically these values, and use a highlighter, these values which are there are for the population, like these are for the population, these are also for the population. So, now the color scheme which I am using is the yellow one is for the population and the red color which I am using is for the sample corresponding values. I will denote by S1 for the standard deviation, which is basically the word is used standard deviate. I am going to come to that later on for the first set, S2 for the second set till the last one which is Xa. So, obviously, X1 bar would be the mean value for the first group. So, technically it will be X11, the first one is for the first set, the second one is for the observations. So, consider there are k number of observations. So, this k may change from group to group, and S1 would be calculated considering I find out and do my calculation accordingly. So, let the group size be n1 to nm. So, this is what k was I was talking, let me change it. So, for no confusion should be there. So, this should be n1. So, the observations are first group has n1, second group has n2 observations, last one has nm observations. So, there are m number of groups, and the sum from x1 for the first one to the mth one are given by sum of n1, n2, n3 till last one. So, this is what I will again highlight using the yellow color. So, if you see the overall mean value, so this is the mean value which is mu I, which will be x1 bar depending on whether using the sample of the population multiplied by the frequency sum them up for all the values of I is equal to 1 to m. So, this m is basically for this, I am again denoting. So, if I want to find out the overall variance, so overall variance would basically be considering the individual variance and the group wise variance and the overall one. So, it will be 1 by n, where n is the total set which is here. So, this is coming here. So, remember that multiplied by in the bracket ni into ni space n1, m2, n3 till nm multiplied by sigma I square for the corresponding groups plus the difference between the average value. If you remember, so this one, so this is being replaced by ni into mu I in the bracket mu I minus the mu overall. So, mu overall is 1, and change the color scheme or else it will become difficult. So, this is going to come here, so based on that I square them up, find out the overall value. So, this gives me the overall standard deviation, this gives me the overall value, average value. In a batch of 10 children, the IQ of the dull student is 36 below the average IQ of the other children. So, this is just a simple problem
which you are trying to utilize using the concept which you have just studied. We are required to show that the standard deviation or IQ for all the children cannot be less than 10.8. So, if the standard deviation is actually 11.4, determine what is the standard deviation when the dull boy is left out. So, now we have 10 children and the IQ of the dull children is 36 below the average IQ of the other children. So, let us divide two groups, which is m is equal to 2 in the first group or in the second group, wherever you put, there would be 9 students and 1 student which is the dull one. Based on that, we will do the calculation. So, let us proceed. Let us take k as 2 such that n 1, which is the dull student, in the observation size is 1, for the other group observation size is 9, because there are total 10 students. It is given the difference between the mean value for the IQs between the dull student and the rest is 36. So, it will be mu 1 minus mu 2 is 36. So, obviously, it is the dull students would be lower, and we also know the standard deviation for the only one student being there is 0. Standard deviation for the other group obviously would not be 0, because it will be 9. Based on that, if we do the calculations, we find out the overall comes out to be 0.9 sigma 2 square, which is for the second group where there are 9 students, plus 116.64 whole square root of that. From the above, we have the overall standard deviation has to be greater than 10.8 as we proved, and if the overall value is 11.4, we find out the standard deviation for the group which is 9 student comes out to be 3.9. Now, I will discuss something about the random event and few definitions of that. So, let us go slowly and try to understand that. So, what we mean by random event? So, random experiment. So, in an experiment where the outcome cannot be predicted with certainty, like tossing the coin, rolling the die, or what is the probability that a car would be going through the street, considering there is some distribution for the car flow, or consider that there would be rainfall, considering there we have the information set for the distribution as such, or the telephone calls are doing, or how much time the teller machine will take in trying to process each and every person who is approaching the machine. The machine means the dispensing machine or the cash or the counter from where you are trying to basically either deposit a check, encash a check, update your passbook, and whatever it is. So, in this experiment, the outcome cannot be predicted with certainty, but you would definitely have some underlying distribution to do that analysis. We will come to that later on. Now, the sample space, which is the capital phi, is basically the set of all possible outcomes of the random experiment which fall into that for that experiment. Now, let me give you an example. Consider you are tossing a coin, and we want to toss the coin only twice, not more than that. So, in that case, the overall sample space can be as follows. If the first toss is tail, consider the second toss is also tail. So, it is tail tail. So, that is one of the element for the sample space. First toss tail, second toss head. So, it is tail head. Third example is head tail, and the fourth example is head head. So, if we have these 4 points, basically makes the sample space based on which you can do the experiment. Now, consider a different type of example. I say, and we will consider these examples later on, I say that let us consider the sample space till we get the first head. So, the example can be put like this: the points or the sample space now technically is not finite, but infinite. Why? Because if the head comes in the first toss, that is one of the point. What if the head does not come in the first toss? So, it will be tail head. What if the head does not come in the first 2 tosses? It will be tail tail head. What if the head does not come in the first 3 tosses? It will be tail 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 head. If you basically think, it can basically be extended to infinity, such that the overall sample space now would be a head, tail head, tail tail head, tail 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 head, and basically go into infinity. So, we will basically consider the case where the sample space is infinite. The sample points would be the elements of the sample space. So, in the example which we considered, for the sample space which is finite, which was basically head tail, tail tail, tail head, head head. So, obviously, these 4 would be the distinct sample points which we have, and if you consider it very simply and think, then the corresponding probabilities in all the 4 cases when there is a finite sample space would be half into half, it will be 1/4 considering all the 4 points which are there. That means, tail tail, tail head, head tail, head head all have the equal probabilities, because tossing the coin, the probabilities of getting a head or a tail are equal, that is half and half, hence it is half into half for all the cases, 1/4. Now, consider the next example which I just gave few seconds back. If you want to basically stop till the time you get the first head, now the observed sample points are like this: head, tail head, tail tail head, tail 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 head, and so on and so forth. So, in that case the corresponding probabilities are not equal, because for the head probability is half, for the probability of tail head is half into half, probability of a tail 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 head is half into half into half, probability of a tail 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 head is half into half into half into half. So, you will see the corresponding sample points are also infinite and the corresponding probabilities are also infinite. Now, consider we want to find out what is an experiment, and we will define an event. Depending on the experiment, it will be the subset of all the sample space which you have, set of all those sample points which you have, such that it will basically define the exact event which you have. So, say for example, I want to find out the probabilities in the first example that I get at least 2 tails. So, in that case, if it is at least 2 tails, obviously the event would be tail tail. So, any event which is head tail, tail head or head head is not counted. If I am saying that here let I have missed something. So, if it is at least 2 heads, obviously it would be, in that case would be a head would have also come like a tail head or a head tail. So, obviously there would be 3 such conglomeration of sample points which will give me the event. Now, in the other example which I said, that if I want to find out that the head comes in the second at least in the second throw, the first and the second would be counted, and if I consider the example that we have to basically toss it 5 times or 10 times depending on what is the outcome. So, obviously the sample points would change, sample points for that event would change, because the sample points of the overall sample space remains the same, such that we will define the event accordingly. So, with this I will close this 4th lecture and continue the discussions in the 5th lecture about sample points, examples, and how we can basically bring that concept in the example of probability and discuss it further. Have a nice day and thank you very much.